I was asked on Discord how to add images to 3D models like in this mug configurator. While some aspects like changing parts of the model, the color, the texture have already been covered in my previous videos, we've never seen how to apply images on top of 3D surfaces. It can look complicated, but it's not. There are multiple approaches to do it. Let's discover what they are and learn how to choose between one or another. Let's start by cloning the Git repository, git clone, github.com, my username, r3f-vit-starter, and the folder we want to put it in, r3f-mug. Now let's open the folder, file, open folder. Now we are inside, run yarn to install the dependencies, and yarn dev to start the development server. We can click on the link here. We have a cube we can rotate around. It means our project is ready. Before starting coding, let's decide what solution we want to use to apply the texture to our 3D object. We won't be using that model because it's there, but let's look at how they apply it. So you can add an image. I will upload my photo, upload image, and you can see it's part of a zone here and it's a canvas. So they are using a canvas and apply that whole canvas into the texture. Why am I sure about that? It's because if I move it fully to the left, I will be at the beginning here, and fully to the right, it will be entirely here. Maybe I can add some text on the left so we see both at the same time. Wawa sensei here. So it's starting there, Wawa sensei, and to the end, we have our picture there. This is a good solution if you want to add multiple images and do some composition directly on a fixed set texture here. This is not the solution we will cover together, but let me show you guidelines so you can achieve it if you want to. You will need on your material to create a canvas texture. You can follow three.js documentation for it, and it's also available using React Fiber. The main thing used by the canvas texture is a canvas element. So how to create that canvas element, which is that zone here representing the canvas used for the texture on the mug. You can go to W3 School and follow their canvas tutorial to know how it works and how to create a canvas using text or images and create your composition like they are doing here. And then you apply that canvas using a canvas texture on the material of the mug. And we will use another solution which is named Decal. What it does is instead of using the material of the mesh and apply our texture on it, then we have to scale it down, scale it up to have our item positioned correctly on the surface. Instead, we are using the geometry of the mesh and apply a texture only on a portion of it. Maybe it's unclear, but we will see together how it works. From the documentation, how it works, we have our mesh, the basic sphere geometry mesh basic material, and on top of it, we will add a decal. So let's copy it. In our code, let's go to component experience. We have our mesh, box geometry mesh normal material. We will add a decal. We import it from dry. We add the debug mode. We can keep the default settings for now. And what we will need is a texture. So first, let's create our texture. Const texture is equal to use texture. I will add an image at the path textures/wawa.jpg. Let's create that folder in public textures. And let's drag and drop our image inside it. Beautiful image. We can save, and let's have a look at what we have. We have our texture applied, but it's completely wrapping it over our existing cube. So let's scale it down. The current scale is at 1. We will use a vector 3. So maybe 0.5, 0.5, and 0.5. But if we do it, we can see it. It's because I scaled it down and it's inside the cube. So you can see the debug mode is here, and we can see it because there is no intersection between our decal and our existing mesh. So we need to move the decal. Let's try to move it, for example, to -1 on the z-axis. Now we can see it's too far away. So there is no intersection between that box and the mesh. So no decal, no texture is created. I guess the perfect position will be 0.5. Now, if we look, we have our decal applied on the box where the intersection is. But you can see we have an issue because they are exactly at the same place, so they are colliding and the camera doesn't know which one to render. Is it the cube or the texture? To fix it, in the documentation, they had that code, but I think it should be applied directly to the material instead. So here, okay. And now we have our decal perfectly applied on our cube. If we try to scale it up on the x-axis, and maybe I will position it on the front instead, you can see it's stretching my image and it's applying everywhere where there is a collision. So if you need to scale it properly, use the aspect ratio of your existing image texture. Me, as it is a square, the aspect ratio is 1, so the x and y value should always be the same. It's easier. You can also move it, for example, 0.2 and 0.2. Now it's slightly on the left and slightly on the top part, and it's only matching here. You can also rotate it. Let's use deg to rad to convert the angle in degrees to radian. Let's say 15 degrees, but maybe not on the y-axis, on the z-axis. And our sticker is now rotated properly on our cube. Now let's try to apply it to a different shape. So instead of that existing cube, let's apply it to a sphere. We simply need to replace our box geometry to a sphere geometry. We'll define its size and the number of segments. Now we have it applied directly on our sphere, but you can see it's truncated here. It's because our collision is only there and it's stopped there. So we need to adjust the position and scale of the decal to be perfectly applied onto our sphere. What we see is the Z position is way too far, so we can reduce it. We can also scale it properly here. And this is what we have. Again, the collision between the box and the sphere isn't perfect, so we should expand the scale of our decal. For example, making it bigger here. It's better, but not perfect, because here it's not matching to. But you have the basic concept. Let's apply it to a proper mesh. Maybe you want to apply it on object. So let's search for mug. We'll be using those ones from Polypizza. Hit download GLB. Don't forget to copy the credits for it. Once you have the model you want to work on, you need to prepare it on Blender. Sometimes it's optional, but for our case, we need to do it. Create a new file, select everything with A, hit X and delete everything. Then File, Import, and import your model. mux.glb, import GLTF. You can see it's way too big. I need to zoom out to be able to see it. So first, let's keep only one mug. So this is one, this is the second one. So this and this, we can remove it. The arc, we can remove it too. I don't need the coffee inside, but you can keep it if you prefer. But I prefer to have the empty mug. Then we can select both. This is optional, but it's easier. Ctrl G or Command G to merge them into one single mesh. Now we need to adjust the center of the item. So let's go on the top view, move it so it's perfectly centered. Object, apply, all transform. So now the center is at the bottom of the element. It's very optional, this part. It's just to show you how to prepare correctly a model for three.js. Then if we go to the dimension of the item, it's 46 meters. It's way too big. We can scale it down, maybe to something around 3 something. Okay. So now we can zoom in and it's a better size. Maybe it's too big. I don't know yet. Usually it's not a big deal if the scale is too big. You can scale it down using React 3 Fiber or three.js. But when using the Decal library, it's easier to work with the right size at the beginning, so you don't have to scale it down and scale up the decal, as it is a child of the element. Or you would need to separate them and to use reference. So it's easier to have a well-prepared model. So now we have it, we can apply all the transform. So the scale is at 1 and the dimension are set correctly. Now we have this. You can see that on our model, we have different materials applied to it. But if we look back at how a decal is applied, it's applied on a mesh. And because we have multiple material, we will have one mesh per material. And we need to apply our decal to one single mesh. Here, the issue that we would have is because there are two colors, we would have one mesh and one material for the top part and one other for the bottom part. So we need to have one single material where we want to place our sticker. Hit Tab and switch to Edit Mode. Then you can switch to Face Mode Selection and select all the faces that you want to apply your stickers to. So it can be fastidious. Use Shift to add or remove them. You can hit Shift and select other one, of course. And you can do it in multiple steps. Maybe there is an easier way, but I'm no Blender expert yet. It's in my plan. Okay, here, same. Maybe we don't want to apply it on the arc here. Then we can start back. We have one distance, so maybe here. Okay. So on that part, we will want to be able to apply our sticker. Okay. Okay, so this is that zone. We want to be able to put our sticker. So use Shift D to duplicate it and hit Escape so it doesn't move. If I try to move it, you can see we have that portion here. Hit Escape and keep it there. Now we have it. What we can do is add a new material here. You can create a new material, name it printable, but of course name it as you prefer. Change the color to something else, but it's no importance because we will render it transparently and just apply our texture on it. And hit Assign. You can see it, but if we move it, we should be able to see it. Now our model should be ready. We can do File, Export, GLB, GLTF, go into your public folder, create a new folder named Models. Well, keep your organization, but it's easier to go this way. mug.glb and hit, or maybe we can compress the geometry and export GLTF. Now let's get back to our code. We run gltf JSX to convert our model into a code file, public models mug -o to rename the component it would generate, so source, components, mug.jsx, and -r public to define the root folder for the import. It generated a file, which is mug.jsx. By the way, sometimes gltf JSX doesn't work with the CLI, so you can use the online version available here, and it works exactly the same. Okay, we have our component. You can see we have all the different meshes, and we have our mesh that we just created with the material printable, so we can work using it. We will rename the function, so our component is named mug, and in our experience, we will comment it for now. We will render our mug. Let's restart the development server, hide it. So maybe it's a bit big, but let's work with it. It's okay. It's entirely black because we need to add some lighting to our scene. For now, let's use environment. Preset is equal to city. We can now see the correct colors onto our mug, and we see that the material from our printable zone is colliding with the original mug. Let's try to apply the decal on that material here. We have already the code. We will be using the same. So the texture, we will move it from mug, from experience, to mug. Don't forget to do the required import. Go back to it, copy just the decal part, and save. Go back to mug. And where we need to apply it, it's on our printable mesh. So we remove that to be able to put content inside. We don't need the material that we created. We just need the geometry to know where we apply it. So we can instead remove it. Use a mesh basic material, transparent, opacity of 0. So we don't see the original geometry here. And then we add our decal to that geometry. So don't forget to do the import. Maybe we can remove the rotation here. And first, let's see what we have. Can we see anything? No, but if we go below, yeah, we can see our debug box. So it's very useful to know where it is and what is happening. So we need to move it so it interacts correctly with one of the side of our printable zone. Let's change the position. So on the X, we'll keep it 0. We'll put it on top. And as it's a bigger one, we'll set the Z position to 1. And let's try to increase a lot the scale. 1.5 everywhere. By doing this, our mug is now colliding with that box from the decal. And you can see it's applying our texture to it. But let's say we want to let the user select the position it wants to be, like it was on the example. Like it was here, we can select where it is positioned, but we had to manually move it on that canvas to be applied on our mug. But because of the system of the decal, it's not very easy. If I want to put it slightly on the right, it's not just moving the X position. This is what it does. It's moving it on the X, but you can see our box is not rotating toward us, and the portion where it's applied is not perfect. So let's see how to do it automatically without any constraint. So we will be using Leva library to add some UI to be able to adjust the angle and the scale. To do this, we need to add Leva library, yarn dev, and we can hide the terminal. Now we can use controls to have Leva controls, and let's create one for the angle. So what we will have, minimum will be 0, the maximum will be math.pi multiplied by 2, so it's 360 degrees in radians. Default value will be 0, and we can define the step. So we go from 0.01 every time we move the slider. Now we have the control on the top right. We can adjust the angle, but we need to apply it onto our decal. But we need to do some calculation. Let me show you something. If we use a reference to the decal, where is it here? Ref is equal to decal. And if we want to just rotate using the angle, so on change, we'll have the value. We'll change the Y rotation to the value. What will happen is if we rotate it, it won't work perfectly because it's moving the group and it's not calculated every time. So we have only the position where it collided, and here it's not representing correctly what we have. Instead, what we will do is not using a reference to it. We will directly assign a new position and rotation for our object. So let's create them. So position will be pause. We'll be using a state so we are sure that the decal is re-render and retry to find the intersection between the mesh and our decal. Const pause set pose is equal to useState of our array. We'll do the same for rotation and maybe for the scale. What values do we have? So here it's a rotation and scale. Okay, it's 1.5. So let's remember it. Here, this is the default rotation we had. And scale, we said 1.5 everywhere. Let's check we didn't make any mistake. It's okay. Now, when we will rotate our angle, we will need to change the position on the X and Z axis. So we can define our new X. It will be equal to math.cost.value. Copilot automatically knew it, and this is basic geometry. You can refer to Pythagorean trigonometric identity to understand what the sinus and cos refers to with our angle. Or you can just copy paste my value. So const z is equal to the sinus of the value, and we will have our X and Z position based on our angle. Now we can set our position. We'll use our existing position. And we will say X pos 1, so it keeps the existing position we have on the Y-axis and the Z position. Let's have a look at what we have. So first, it's applying here, which is a zone where it's not printable. But if we rotate it, you can see our cube is following that angle every time because we are adjusting the x and z value using cosinus and sinus. But where it interacts, if we rotate it maybe here, you can see we have an issue because we are not rotating our decal, so it's not applying it perfectly where we want. As you can see, the box doesn't rotate and it's poorly positioned and it's not exactly what we want at the beginning, which is perfectly aligned and perfectly scaled and positioned. So let's calculate the rotation. We are using the tangent using x and z to find the angle of rotation to have it facing us. Now we need to rotate, so set rotation with our previous rotation. We'll set, well, we don't need our previous rotation. We'll set 0, the new rotation on the y-axis, so it's facing us and it's turning in the right direction, and 0 on the z-axis. Now if we reload, well, it's not the best default position, so let's change it. Let's say math.pi divided by 4, and the minimum, because it shouldn't be 0, it should be maybe Decal to 15 degrees. And here it shouldn't be 360, maybe it's to 70. Okay, now what do we have? We start here. The minimum, it's still too much, so we will change the minimum. But the maximum is not enough. So let's just adapt it. But you can see if we rotate it, well, it was what we were talking about. So just let's have a look at it. If we rotate it, you can see the rotation of the box is always perfect. It's rotating accordingly to the angle. It works as if it was in a group and we rotate the whole group. Maybe we could have done this. I'm not sure if it will recalculate the decal, but you can give it a try. Let's adjust a bit this. So 330 maybe and 30. Still not enough. Okay, let's say 60 and 300. Okay, let's try to reduce it. Looks nice. And if we go far beyond, it looks nice. So now we can position our sticker wherever we want. Perfect. Let's add some control to change the Y position and the scale. So let's name it pos Y. It will be equal to minimum 0, 3. Our value is 1.8 because it's our default Y position here. Okay. Set position will keep our X and Z position, but it will set our Y value here. Perfect. And for the scale, okay, minimum maybe 0 is not enough. So 0.5, maximum 3. Our value is our default value, and we change the scale accordingly. But we are happy with the Z value, which is the depth of our colliding box. So let's keep it to every time 1.5. Let's see if it works. If we change the Y position, we should put better limits, but you can see that it's working correctly. It's applied. As we did for the angle, we can adjust the Y position. And for the scale, we can make it bigger and have a big wawa or a smaller one. So far, we've been using an image texture which has no transparency. So let's change it to a PNG. I removed the background. I can add it to the texture. Okay. And let's see what we have. You can see that the part that should be transparent is green. It's because on our decal material, where is it? Here, we should make it transparent. So it handles transparency on the texture image. Now we have our transparent sticker working correctly on our mug. Of course, this is the system for one sticker, but you can add as many decals as you want and create your composition from it. Let's make it look a bit better to finish this video. First, we can remove the debug to not show the colliding box. It's only useful when we are trying to find the right values. Then let's go to experience. We can get rid of that code. The environment, we'll set it as background and blur it. Let's wrap our mug into a float component, so it will float in the air. And we can add a contact shadows slightly below at minus 0.5. We set the opacity to 0.4 and the blur to 2. Thank you for watching. I hope you enjoyed this introduction to decals. If it's the case, please hit the like button as it really helps this channel grow and be more visible to other developers that might like 3D web development. Let me know in the comments below if you want to dive deeper into those techniques. I could make some videos covering it. If you want to dive deeper by yourself, there are some good examples like this bunny or this ring. I will put the links in the description. But good news, there is nothing that we haven't already covered. Don't forget to subscribe to not miss the upcoming videos and continue learning by watching this video tutorial available here.